Solving equations. All right. First of all, you know a little bit about solving equations. For example, you know how to solve equations that look like this. 2x plus 9 equals 0. Your goal is to isolate x. So you subtract 9 and divide by 2. And you probably find that x has to be negative 9 over 2. So you know how to solve equations. And we're going to solve all types of equations and polynomial equations in this video. So basically, it says solve the equation for x. They don't always give you this for x part. If they don't, and the direction just simply say solve the equation, it's implied that you should solve for the variable in the equation. In this case, the variable is x. We have lots of ways we can solve this equation. This equation being quadratic, one way I can solve it is factoring. And the first way I look to solve it is see if I can factor. You can decide in about 10 seconds, maybe 15 seconds, whether or not this is actually factorable or not. If it is factorable, you'd factor it, then you'd set the factors equal to 0. And another way we learn to solve equations is if it's quadratic, as this one is, we can use the quadratic formula. Quadratic formula, which is negative b plus or minus the square root of b squared subtract 4ac all over 2a. And the third way can work for any equation, whether it's quadratic or not. You can graph it. You use any one of those methods to solve a quadratic equation. However, if it's not quadratic, factoring is a possible option. And no matter what the degree is, quadratic, first degree, 15th degree, you can always graph it to find solutions. And we talked about that in day 4's video, where we look for approximating the zeros. All those rules still apply in solving equations. All right, so we're going to actually solve this equation all three ways. We're going to solve it by factoring, we're going to solve it by quadratic formula, and we're going to solve it by graphing it. Okay, so let's say we factored it. We would take this equation, 2x squared, subtract 9x, subtract 5 equals 0. And we'd first decide which type of factoring technique might we use. Being a trinomial in quadratic form, we probably use the fact that it's quadratic form to factor it. And in that case, we want a leading coefficient to be 1, so we multiply this 2 to the back with the constant, making x squared subtract 9x subtract 10 equals 0. Now the goal is to figure out what the two factors are. So if we take this x and split it in half, we get an x here, get an x here. If you remember, this sign tells me I have unlike signs, so one of them is positive and one's negative. And I have to figure out what multiplies to be 10 and adds to be 9. Well, that's pretty easy. It's 10 and 1. And don't forget, since you multiply by 2 to begin the problem, you have to come back and divide this by 2. So the equation still balances out. So what we have now is, this says x plus 1/2. 1/2 does not reduce. So the fraction becomes, so the factor becomes 2x plus 1. This says x subtract 10 over 2, but 10 over 2 reduces. That reduces to be 5. So get x subtract 5 equals 0. Now in day 3's video, we learned to solve equations was in factored form. So if I gave you an equation in this form and I asked you to solve it, what we learned was we then set the factors equal to 0. Equal to 0. So anyway, I would take 2x plus 1 and set it equals 0. And I'll take x subtract 5, set it equal to 0. One of my zeros, when I solve this equation, I subtract 1 and divide by 2. So x equals negative 1 over 2. In this one, I add 5. So x equals a 5. So my zeros is negative 1/2 and positive 5. So I know for sure those are my zeros. However, we got other ways we can verify. We have other ways we can make sure those are the zeros. Another way we can actually check it out is using the quadratic formula. All right, so if you remember from quadratic formula, the leading coefficient is a, the b value is the linear term, and the constant is the coefficient of the linear term, and the constant is a constant on the end, c. So if that's the case, we plug all these numbers in, and it says negative b. So I would always start off by, if I'm going to use quadratic formula, I'll begin by writing out what the formula says, negative b plus or minus. Negative b plus or minus the square root of b squared subtract 4ac all over 2a. All right, so if that's the case, I could take this negative b, is already negative, so now it's negative 9, plus or minus the square root of negative 9 squared, subtract 4 times 2 times negative 5, all over 2 times 2. And if that's the case, what we now have is negative 9 makes positive 9, plus or minus the square root of, that's 81. And then a negative 4 times a negative 5 makes that positive. So it's a positive, 4 times 5 is 20, times 2 more is 40. So positive 40, all over 4. So that gives you 9 plus or minus the square root of 121 over 4, which leaves you with 9 plus or minus square root of, square root of 121 is 11. So it's 9 plus or minus 11 over 4. And if that's the case, we could divide this in two answers. One of them is 9 plus 11 over 4. And another one is 9 subtract 11 over 4. So 9 plus 11 is 20 over 4, which is 5. 9 subtract 11 is negative 2 over 4, which is negative 1/2. So again, my solutions are the same as I got at first. 5 and negative 1/2. With quadratic formula, it's still 5 and negative 1/2. So either way it worked if it's a quadratic equation. And the third way we can actually solve it is graphing it. So I need to make some space here. So if you need any of this stuff as a note, well, you should need all of it as a note. Pause the video and be sure to copy down everything that you see. But go ahead and pause it down, because a lot of this stuff is about to disappear. If you intend to graph it and you don't have a graphing calculator, go back to our class website, and on the side of the screen you'll see online graphing calculator. You should click it. And then when you get there, you have a place you can plug in this equation. It's 2x squared subtract 9x subtract 5. After you get there, you hit graph. Now after you graph it, we're looking for the place across the x-axis for our zeros, or our solutions to the equation. This is one place. You can clearly see this is a 2, and this is 4, and this is 6. So they're counting by ones, and this place it crosses is at 5. So one solution is at 5. And then you can see over here, if this is negative 1, and that's 0, that looks to be right smack dab in the middle of it. So it looks to be about negative 0.5, or negative 1/2. But to be sure, I can check it. I can go over here, take one of those numbers, actually replace it with negative 0.5. And if you notice, right over here it says it's 0. It's very close to the edge of the screen, but it says 0. So I know that negative 0.5 is 0. And for that matter, at positive 5, if I type in positive 5, is also 0. What's great about this is this table actually gives you outputs for different numbers all around the curve. So at negative 4, I know that's negative 63. At negative 2, I know it's positive 21. At 0, I know the output's negative 5, and so forth. So it's great. It's already can give you the outputs of the function just by you telling it where you want the output to be at. So at 1, I know it's negative 12. You can't see the 2, but it says negative 12. So again, our goal is to find the zeros, and the zeros are here and here, negative 0.5 and 0. So we solve that equation 3 different ways. We solve it graphically, we could solve it algebraically with factoring, or we could solve it with a formula, which would be the quadratic formula. Great. So that's pretty much all I can tell you about solving equations. Everything else just deals with using factoring to solve or graphing to solve. So let's continue with some other problems. All right, so again, direction is simply solve the equation for x. In order to solve the equation, before you begin, you must set one side equal to 0. One side of the equation equal to 0. This is if you have more than one variable, or more than one exponent, more than one variable to different powers, whatever. So you got to get one side to be 0. If it was just x plus 2 equals 0, well, in that case, or x plus 2 equals 11 or 7, you just simply isolate x by moving everything away from the x. So it's pretty simple then. We just have one variable. You can just isolate the variable. So you subtract 2 from both sides, and you get x equals 5. That is the most practical way of solving that, and that'd be it. And if it's already set equals 0, you just subtract 2. But in this example, we have two variables, and both of those have their own powers. So it's impossible to just isolate just the x to the fourth or just x squared and try to solve it. So in this case, the rule is you must set one side equal to 0. So let's actually do that. So if we rewrote this equation, I could subtract 8 from here, subtract 8 from there. And this side is now 0. And this side is now x to the fourth, subtract 7x squared, subtract 8. And then we pause for a moment and we see if we can factor it. Take a look at this and tell me if you can factor it. If you can, go ahead and factor it. So pause the video and factor it now. So if you did that, you should have got the factors be x squared, subtract 8, x squared plus 1. The next step, set these factors equal to 0 once you have it in factored form. So no x squared subtract 8 has to equal 0. And x squared plus 1 also equals 0. In solving this equation, you probably add 8 to both sides. And you get x squared equals to 8. And you can square root both sides. And you get x equals to positive negative square root of 8. Square root of 8 can be written other ways. You can call it 2 square root of 2 if you want. I'm going to leave it there for now. In this one, if you solve it, subtract 1. You get x squared equals to negative 1. You square root both sides. And what we get is x equals to positive negative. The square root of negative 1, you already know is I. So in this case, my solutions are positive negative square root of 8 and positive negative I. So in this case, we have 4 answers. X could be positive square root of 8. Positive square root of 8. X could be negative square root of 8. X could be I. Or negative I. So it could be any of those. So there's 4 different answers. If we look at our equation kind of tells us we have 4 different answers. If my degree is 4, well, I should have 4 solutions. And some of my solutions could be imaginary. But those are the solutions to it. One last equation. So be sure to copy down everything you need, pause the video. I'm about to erase all this stuff. Okay, so in this problem, it says solve for x. And truly, we have 2 ways of solving this. Because I only have one variable, I can truly isolate the variable. So my first step could be isolate x. So if that's the case, I could take x cubed, subtract 27, and the goal is to get x cubed by itself. So you add 27. And you get x cubed equals to 27. In this case, I could cube root both sides. And I get x equals to 3. So that's a perfectly fine answer. However, if we look at our equation, how many solutions should we have? Well, this tells us it should be 3, meaning that we lost some solutions. This is my only real solution. However, I have some imaginary solutions. You only get those by factoring. So we can factor that polynomial because it's the difference of 2 cubes. It factors be x subtract 3 times x squared plus 3x plus 9 equals 0. But look at this part. I know when I set that equal to 0, I get 3. But on this side, I can't factor it, so I have to use quadratic formula to find the solutions. So I have to take the factors and set it equal to 0. Use quadratic formula. I'm out of time, but you should have found to x equals this as solution. Notice it has an I, means the solutions are imaginary.